Thanks for joining us. So we'll be stepping through a little bit of background on the company, the U.S. team, as well as the products that we have. And then I'll hand it over to Igor to talk about our repowering and how we provide solutions for that. And then we'll also have a Q&A session. So with that, let's get started on Solis. So who is Solis? Solis has been in the industry. It started about 20 years ago in 2005, and we've been in the U.S. market since 2009. The company was first publicly traded in 2019, and we are now the third largest inverter company in the world. Next slide. So when we look at the numbers for Solis, there you can see we have over 4,000 employees globally, and we also have manufacturing capacity that exceeds 80 gigawatts each year. We also have close to $3 billion in assets, and the bulk of that is our own manufacturing. So our founder is very much a believer in manufacturing our own products and controlling our destiny. So we do not outsource anything. Everything is manufactured in-house. So if we look at our manufacturing capability, you saw on the previous slide that there was a picture of a robot. So everything is done robotically. There is no hands touching the manufacturing process from the beginning to the end. And the other thing that we do that is unique is we do 100% burn-in testing of all of our three-phase inverters for 4 hours. And that's at varied temperatures, temperature extremes from low to high, and also full power. And then after that, we do a functional test. And you could see there's actually a picture of our manufacturing plant in Ningbo, China, which is a couple of hours south of Shanghai. And we also have a plant that we've opened up in Vietnam that has about 4 or 5 gigawatts of capacity that will be coming online a little bit later this year. So when we talk about Solis reliability and quality, we use tier 1 suppliers globally, and here's a good sample of the suppliers that we use. Very well-known names. We work very closely with them, and in fact, they sign our ESG requirements in terms of meeting ESG goals and objectives like we do, and we stick with them. So even through COVID, when everybody was short on components, we didn't switch components away from these tier 1 suppliers. We just continue to work with them to ensure continued supply, continued quality, and reliability of our products. So the result of all of that for Solis is reliability. We work with DNVGL. They did a reliability report and lifespan report of our inverters, and they determined that we have a 25 plus year lifespan on our inverters. So if we look at the organization, our US organization, this is the team. Actually, in the middle of the picture in the gray shirt, you'll see Jimmy. Jimmy is our CEO and founder. And next to Jimmy on the right is James Chow, and he's our general manager for the North American market. And there's the rest of the team. So the team has grown very significantly over the last couple of years. 2 years ago, there was less than 7 people on the team. Now we're close to 45. If you click on the next. And this is the support organization that we have. And we really have everything that we need to be self-sufficient in the US market. And that includes application engineers. And we've got Zach on this call as an example of part of that team, all reporting into Igor, as well as product management, obviously outside sales, inside sales. We have a field service team spread across the country to help customers with commissioning and other field support, as well as the marketing team and quality. And here's another snapshot of Solis in the U.S. Our U.S. headquarters is in Texas. We do have a 3PL warehouse in California where we keep safety stock, along with RMA inventory, where we like to carry approximately 6 months of inventory for RMA, and that is kept separate from new product shipments to support existing installed base. We are planning a warehouse and a lab in the U.S. where we could support more local R&D efforts and testing and quality of products. We work with distributors, and we do sell direct as well for large accounts, but there's a list of some of the distribution partners that we have in the US, but also supporting Canada. So how do you design and how do you work with Solis and interfacing with the team? Well, it starts with the team that's on this call here, but we also have a lot of tools on our website that gives you the ability to do plant designs with our PV string sizer tool, service support contacts, access to all of our data sheets, manuals, application notes. So everything is on our website. You can even do warranty extensions if you're looking to extend warranties beyond the base warranty. And actually, we only have 28 alarms that come out of the inverters. And if you want to know what all the alarms on, you could actually Google search that under Solis inverter alarms, and you'll be able to access all of them. So in terms of service and RMA support, we have a call center, and every call that comes in is logged into the system. And what we've been experiencing so far is 80% of the tickets are replied to within 1 hour, and the remainder within 48 hours. RMAs are prioritized and expedited, as I mentioned, out of our 3PL warehouse in California. And for any any RMAs that we're not able to support or more difficult issues, it's escalated to the field service team or Igor's team on the engineering side. Typical wait time for a call is a little over 2 minutes, and the average call duration is only about 6 minutes. And you could see a list of some of the components that are field replaceable or serviceable under Solis supervision. So not a lot of components that do need to be replaced. And then, of course, if a full inverter needs to be RMA'd, we could do that as well. So now let's talk about the Solis, three-phase inverter line. It starts with our commercial inverters, the smallest one being the 20 to 60 kilowatt platform. Those are 1000 volt, 480 volt AC, 1000 volt DC, 480 volt AC. And that line also has a 30 kilowatt 208 inverter if you have 208 sites. And inverters have lots of MPPTs that could also accept Y connectors, and you'll see some slides coming up on what they look like. So very compact, easy to install, and that's for rooftop type projects. The next product would be the 75 to 125 kilowatt, also 480 volt. We do have a 60 kilowatt three-phase 208 inverter coming up, and once again, same thing you'll see on all of the inverters in terms of being able to string them. And this is a unique size inverter in the industry that gives you the ability to put fewer inverters. We often see inverters on the market go up to about 60 kilowatt for 1000 volt, 480 volt AC, and we could actually go up to 125. Very wide MPPT range, which will show when we come why that's important once we get to the repowering part of the presentation, and you'll see that across all of the inverters. The next inverters are large commercial, small utility, 1500 volt inverters. So that's the 125 to 185 kilowatt. And then finally, we have our largest inverter, which is the 255 800 volt AC inverter, and soon to be released a 350 kilowatt inverter with different sizes depending on the AC voltage. So now we'll talk about the inverter features that are common to all of our three-phase inverters, and we'll start with string level monitoring. So you have string level monitoring capability on every single inverter from 25 kilowatt to 350. We also have advanced IV curve scanning. So if you want to do IV curve scanning remotely, you can do that with our inverters. No combiner boxes. Combiner boxes can potentially be a failure point. We have all of our connections are directly into the inverters with MC4 Stably. They are fuseless designs, so all of our inverters have 2 strings per MPPT, and because of that, you do not need fuses, which are another potential failure point. As we saw on the previous slide, you can support Y cabling if you want to do in-field string combining. We have nighttime PID recovery for those that are experiencing issues with modules and PID. We also have intelligent AFCI on all of the inverters, and you could isolate the MPPT if needed of the inverters that are having issues. We have type 2 surge protection on both the AC and the DC. Convection cooled, but fan assisted. So the inverters will operate without fans going, but you do have fans for more cooling. NEMA 4X C5 anti-corrosion level for the enclosures. Low startup voltage and very wide MPPT tracking range. So again, you'll see why that's important for repowering. Reactive power compensation, if that's required for your site. We can do remote firmware upgrades via our Solis cloud, and that's our monitoring platform. And next, we meet all of the standards that you could think of, as shown here. And in terms of communication flexibility, we have our own communication data loggers, or we could work with any third-party platform. The important thing is we're Modbus RTU or SunSpec compliant, so whatever you have, we could communicate with. Some of the features of the 1,000-volt only inverters are integrated DC and AC disconnects, and on the 1,500-volt inverters, we have PLC capability, if that's the preferred method for communications, and we're also in the process of working on DC coupled storage for release in 2025.
Good afternoon, everybody, and thanks for joining the webinar. So I will cover the repowering solutions that Solis can provide and support. First, we'll discuss why would you need repowering. So the repowering is right now becoming a very hot subject because some of the inverters are getting older, 7 to 10 years, maybe some even older than this. And those are usually older inverters that were designed with the 600 volt, sometimes with the 1,000 volt DC, and really those type of DC connections are no longer exist or available in the marketplace. So inverter failures, it's very common now with this 8-10 years inverters. Costly maintenance repair, so even if it's possible to repair some of those inverters, it does cost a lot of money to repair and service. Parts availability issue, a lot of the inverter manufacturers that are produce those inverters no longer in business or no longer supporting those models any longer. And then warranties, usually those inverters are out of warranty. So usually they were 5 to 10 year warranties, and by now most of those warranties are expired. Now, how to replace the inverter? Is it direct replacement possible? And currently it's not that simple because of the issues we mentioned earlier. 600 volt DC input voltages, that's not available direct replacement currently with the central inverters that available on the marketplace. So we are providing alternative option using a 1,000 volt and a 1,500 volt DC string inverters where PV grounding is not required. And we also have a 1,500 volt string inverter that utilizes anti-PID option, which is PID during daytime when negative grounding is required. Key consideration when doing repowering. So what we do is basically the way we evaluate the repowering projects is basically based on the output voltage range. So we look what is the voltage of the output that's required. So is it 208 to 800? We can consider those voltages and those inverters to be repowered with our inverters. And the main reason for that is because to keep the interconnection the same. So the purpose here is not to change the transformers or not to touch any of the switch gear, and that's for we trying to keep uh, the interconnection or AC voltage the same. The other part is the PV side. So we looking into, because of the older module, in most cases we would need to parallel multiple string in the single MPPT, and that's where we evaluate the short circuit current rating of the current PV modules to make sure they could be combined and connected to the single MPPT inputs of our inverters. And then based on the output voltage and the input voltage rating that is required to decide, we will derate the output power of the inverter to meet those requirements, to make sure that inverter is operating in a safe operating area and we meet the requirement of the site. PID repair function for ungrounded PV strings. So with those new inverters, they all build in PID recovery, which is a PID during nighttime, which could recover some of the degradation that caused by the PID on the current modules. Also, some inverters has anti-PID function with negatively grounded PV strings. So that's where if you have application where the grounding must be negatively grounded, we can use the anti-PID function to pull the ground potential above minus PV potential, and therefore basically achieve the same result as the grounded system. Solis inverters that are considered for all the repowering projects, there's about 5 models that we consider, and that's why the process is not simple. With one model, it's very difficult to accommodate all those repowering. So there are 5 models, which is the 100 kilowatt 480 volt, the 60 kilowatt 208 volt, the 30 kilowatt 208 volt, the 255 690 to 800 volt range, and then 300 kilowatt 690 to 800 volt range. So those are all the models that we will be reviewing how we can repower different central inverters. The question is many times asked is why would I need to repower, right? So do I need to repower? And the decision need to be made basically based on reviewing the financial. Does it make sense for me to repair? And it's weighting the operating expense of repair plus potential loss of revenue due to the inverters not producing the power or partial production of the power versus the capital expense that need to be invested into the repowering project and the PPA purchase power purchase agreement contract terms, right? So this is the first financial decisions you have to make sense to do the repowering. The next thing is will be selecting based on the AC, based on the power, AC power, and AC voltage requirement. So that way you don't need to touch your interconnection and do not, maybe in many cases, do not need to provide a interconnection study again and so forth. The third thing is you need to choose the right partner because you need to choose the partner that will be there, will support you in the long term, and kind of learn the lessons from the first, I guess, project powering that some of the partners that was chosen are no longer in the business or left the business or no longer support the business. So you need to choose a partner with high volume manufacturing to ensure that they can supply the product and supply chain continuity. Bankable company that committed for long-term inverter manufacturing. So there was a lot of companies that were bankable in the past, but that was not their core business. So they decided to leave the business and to basically abandon those installation and those projects. So you got to make sure that the company, the main core business is inverter design and inverter manufacturing. Inverter manufacturing design, a core company business. So that's kind of what we mentioned. wide selection of product, so that gives you flexibility and also flexibility in the future. So if you need to replace with something, make sure it's uh, also backward compatible. Streamline repowering proposal process, so simple proposal process, something that we can do and support our customers. And technical guidance, so provide guidance and solution and advices basically to the customer on the repowering project, because there's obviously more than one way to do it. Next, we will compare to repowering options, right? So there are several options that are available for repowering using string inverters, possibly using some central inverters, or design some kind of custom product that could accommodate some of the application. So first, we'll review the advantages of the string inverters. So wide selection, as we show, we have 5 products that could do the job, and we can fine tune the product to the specific job or the specific repower project. Uh, Flexibility for various voltage and configuration. So we can accommodate low voltage on the DC side. We can accommodate low voltage and high voltage on the AC side. So it's very flexible from that perspective. Backward compatible between generations. So what that means is if you have, for example, 100 kilowatt today from Solis that you replace and doing repowering project, we will be backward comparable in another 5 years with a similar product, maybe with more features, maybe with additional certification, but the product will be similar and will be backward compatible. And O&M replace versus repair model. So there is no trained technicians or service people that need to be able to repair the inverters. You basically replace the inverters. So you replace with equivalent inverter, sometimes even could be with a different manufacturer, because in a lot of those string inverters, there's multiple manufacturers that are kind of backward compatible to each other. Central inverter challenges, lack of spare parts and warranty support when O&M is out of business. So you could replace maybe with the central inverter again, but it's again will be the same issue 7, 8 years down the line, and you will be facing the same problems and the same challenges. Newer model, not an option due to higher power capability and voltage. So most central inverter newer models are designed for 1500 volts DC application, and most of them are much higher power. So the trending models are 4 megawatts or higher. There are some maybe available at the 2 megawatt range, but again, those are pretty much obsolete models that are might be still available in the marketplace. And limited flexibility and availability of exact replacement. Now, if we looking at the design in a custom product for repowering, specific for repowering, it will have a long development cycle. So it's about 1 to 1.5 years to develop a whole new inverter. One inverter model won't cover all application, and multiple custom product will need to be developed. So if you have a large portfolio, let's say 2-3 gigawatt portfolio with various inverter models, one inverter would not cover all those models. As you saw in earlier example, we are needing 5 different models to cover all the different applications. So usually one model would not be sufficient. Custom product has no proven reliability and high risks for deployment. So there is no previous reliability record. There's no previous history in the custom product. So there is a very high risk that you might be deploying a product that is not very reliable to begin with. And it will be kind of single source at this point as well. Long-term availability, because it's custom, most likely it won't be available in the next couple of years or after the next couple of years. And design complexity is high for this kind of custom product. And what I mean by that, you need to design a product that is operating with a 600 volt DC or below voltages, and to have also some of it to have a high voltage ACs that are 690 volts and so forth. So the complexity of the product, it's kind of high there. So what is our repowering solution? Here we will, in this presentation, present different central inverter models that are legacy products that most people are facing now to replace, and how we can replace it with our current models that we just reviewed. So this is taken SETCOM example. So this example replaced in SETCOM PowerGate 500 and PowerGate 680. This is the specification of the SETCOM PowerGate 500 and PowerGate 680, and it's compared with our S5 100 kilowatt string inverter. So kind of those are the comparison on the specification. The first thing we'll review is input voltage range. Can we cover the input voltage range of the SETCOM inverter? And based on this inverter, the 100 kilowatt can cover the input voltage range without any issues. The next thing we'll review the output voltage range. So also here we can cover the output voltage range of the SETCOM inverter. And on the bottom here, we show it will require 6 inverter, 100 kilowatt, to replace the 500 kilowatt inverter, and 9 to replace the 680 kilowatt inverter. The inverter will be derated to 90 kilowatt, respectively, for 500 kilowatt and to 75 kilowatt for 680. And the way the derating is done, or the it's basically for the output voltage of 480 volt, uh, we have no derating, so there is no derating required. But for the low input voltage range of 320 volt, the inverter will be derated to 90%. And that's why the 100 kilowatt will be derated to 90 kilowatt. And therefore, to replace a 500 kilowatt inverter, will need 6 of those inverters. The 680, because the output voltage range it's 550, we don't need to do any derating, and 100% of P nominal could be used. But due to the low voltage AC of 360 volt AC, the inverter would be needed to be derated to 75% of P nominal, and therefore the 100 kilowatt will be derated to 75 kilowatt, and it will require 9 inverters to replace the 680 kilowatt inverter. Here we show the single line, kind of summarizes this. We're using, in this example, Y connectors. So basically we have 2 Y connectors going to a single MPPT. One input takes 2 strings, the other input takes another 2 strings, and you can connect 4 strings per MPPT to this inverter. With 10 strings total, maximum you can connect 4 strings. Typically, the other evaluation we do, and it's project per project, it's to make sure that we replace one inverter with one combiner box. So that way you don't need to rerun or run the DC wiring at all. So it's basically taking the combiner box, replacing it with the inverter one-to-one. And then the only consideration there is you will need to run the AC runs, and sometimes to add AC switchgear. So in some cases, AC switchgear will need to be required to be added to connect all those inverters together, basically. So in this case, it connects 600 kilowatt or 90 kilowatt rated inverters to switchgear and then run directly to the transformer. The same thing with the 680 kilowatt, same idea, multiple strings, up to 40 strings per inverter, depend on the combiner box. We replace the combiner box and then have a switchgear that is combining all 9 inverters and run at 360 volt AC to the transformer, directly to the transformer. This is advanced energy product. So in the same manner, we'll show the example This is a little bit more trickier product because it uses bipolar technology, so it has a plus and minus potential in this case. So it's a little bit more complex in some of those cases to repower. So here we put the specs together of the same inverter, 100 kilowatt inverter, S5 100 kilowatt, compared to AE 500 and AE 500NX. Similar point here, we're looking at the input voltage range. So in this case, we can cover the input voltage range. Obviously, the plus and minus will need to split, and all will need be a plus potential. So those need to be kind of separated potential, which it's typical for AE inverter. And then we look at the AC side. So at the AC side, we can cover the 480, and then we can cover the 420 volt of the 500 NX 1 kV. It will take 6 inverters to replace the AE 500NX, and it will take also 6 inverters to replace AE 500NX 1 kV. And in the same example as previously shown, the reason for derating of the inverter to 91 kilowatt is because 330 volt DC input, and it will be derated to 91 kilowatt. And the 1 kV inverter, no derating for the input voltage because it's 600 volt DC. So though there is no derating for that, but we will need to derate for the output voltage, which is 420 volt AC, and it will be reduced to 87.5 kilowatt respectively here. The same approach here, as shown in the previous examples, we take in 4 strings per MPPT maximum that could be combined, depend on the string design, could be connected to the inverter. So far, in most cases, I haven't seen an issue. 40 strings, usually it's more than sufficient to connect to a single inverter from the current combiner boxes, and then we can connect it to AC switchgear and then go to the transformer. Similar matter here with the AE 500 NX 1 kV. The AE 1000 NX, it's a little bit different inverter, a little bit different model. It has an 800 volt AC output, so that's why we need to use here our 255 kilowatt inverter in this case. So this is a higher, bigger power inverter. So we check on the input voltage range, so we can cover the input voltage range with this inverter. And then the output voltage range could be covered as well. So that inverter is nicely fit to repower the AE1000NX, and it will take 8 inverters to repower a 1000NX, and they will be derated to 125 kilowatt, about half the power. The main reason for that derating is the low input voltage range. The DC voltage range 550, the inverter will have to be derated to 50% of its nominal power. Therefore, it will be about 125 kilowatt based on that. The design is similarly there. This design has the 12 MPPT, and we can accommodate 48 strings. So that could replace pretty much any combiner box that was used with this inverter. And then we will need to connect 8 inverter to the AC switchgear. Each inverter will have its own circuit breaker, basically a combined switchgear to the medium voltage transformer. And this is 800 volt, basically, installation. The next is Ultra, ABB Ultra or Power One Ultra, repowering that inverter. It's a little bit different approach here. So here we're using our 350 kilowatt inverter. And that's our new utility scale inverter. that also designed for repowering projects. We can look at the input voltage range. So this inverter can cover the required input voltage range for the ultra inverter with some derating. And then the output voltage range, it is rated 300 kilowatt at 690 volt AC. So it could cover the output voltage range as well. And it will take 8 inverters derated to 196 kilowatt to replace an ultra inverter. And that's where the 690 volt, it will be 85% of nominal powers of 350, so it's about 300 kilowatt. And then using the 645 volt DC rating of the ultra, the lowest rating of the ultra inverter, the input will be derated to 66% of P nominal. So the available power of the inverter about 200 kilowatt. So that's basically will direct repower the inverter ultra, which is rated 1560. We can generate 1570 kilowatt with this configuration. This inverter again has 12 MPPT, so we can connect 48 strings, parallel strings, up to 4 strings per MPPT, and then have a 690 volt switchgear with a 690 volt breaker going to the medium voltage transformer connection. Solectria SGI 500 also provided here an example. Same approach. We take our 100 kilowatt in this case. This is the input voltage range. The output voltage range is the same, and it will take 6 inverter to replace the Solectria SGI 500. Similar example as before. And then the single line kind of same approach here, showing a little bit different approach. This is actually actual site that we will do in a proposal. We keep the existing 800 amp circuit breaker. We add in our AC combiner box, where we have a fuse disconnect combiner box, where we connect 6 inverters into that combiner box, and then using existing switchgear to run to the transformer. So that's actually, in some cases, we provide this AC combiner box in some solution in order to keep the existing circuit breaker if they are there, if there is existing switchgear opportunities already there. So that's some flexibility there too, to keep the existing switchgear and not to add the additional cost to change the existing switchgear. SMA 500, similar approach, but this one is a 208 volt AC. And that's where we're using our 60 kilowatt low voltage inverter. So at the 208, we can meet the input voltage range with this inverter. It's rated 180 to 1000. And we can meet the output voltage range. So this inverter could meet exactly the output voltage range of the SMA inverter. And it will take 8 inverters to replace a 500 kilowatt SMA inverter. And basically, this is kind of actual proposal that was done in the past, a specific site where we actually use 3 inverters with 25 strings per inverter, and then 5 inverters with 22 strings per inverter. And this is to accommodate the existing string combiners that exist on that specific site. So basically 8 inverters to replace a 500 kilowatt SMA inverter. Another challenge is the negatively grounded system. Most negatively grounded system could be also floating system with anti-PID recovery option, but some PV module, like First Solar PV module, are requiring or must have negatively grounded PV. So the floating system or PID recovery is not an option in this case. With first solar modules, basically string inverters are transformerless, so grounding positively or negatively the PV is not an option, and it will cause a ground fault. Uh, when PV array needed to ground it, anti-PID daytime PID function must be implemented. So that function is kind of touched a little bit earlier. What it does, it shifts the ground potential about the minus PV potential. That way, effectively causing the same effect on the module as ground in the module. And our 350 kilowatt uses the anti-PID, which is PID daytime, not to confuse with anti-PID recovery, uh, in as an optional feature. And basically, here's an example again showing the Ultra 1560 how grounded system, how we can replace with that inverter. The example is similar as before. So the input voltage range is okay, the output voltage range is okay. It takes 8 inverter to replace it. And basically, the difference here is shown this first solar modules. So this is how you connect first solar modules into the each MPPT. So you can connect all those modules in parallel, and this is the arrangement, actual project solution that could be connect. You can connect up to 192 strings to a single 350 kilowatt inverter, which cover a real application with for solar modules and string combiner. So that's an optional method to use for the first solar modules application. Also here I would like to show an example of repowering project that was done kind of combining, in this case, external combiner, but it could be done with Y connector the same way as shown before. In the presentation, added switchgear that connects those inverters to the medium voltage transformer, the rating of the switchgear, and now we'll go to the Q&A session on this presentation.
Yep, I've got this. Thanks, Igor. Is there any extra benefit we could get when repowering a site with string inverters?
Yeah, with the multiple MPPT, you'll be able to gain additional production from the module. So changing from single MPPT, which is most central inverters that currently are that we're repowering, with multiple MPPT, you will be gaining some of that production. For especially with the older module, you have a greater unbalance of those modules. So multiple MPPT will gain several percentages on this. Also, multiple MPPT will give you better understanding of your unbalance between the different modules and different state those modules are in, like maybe some broken, maybe some are dirty, maybe some need cleaning, maybe some damaged. So with multiple MPPT, you'll be able to see real time actually module performance. Aside that additional power performance, I've been told between 5 to 10% are gained, especially on the older modules.
Excellent. Thank you, Igor. Another question for you. Do you provide any support with the design of these repowered projects?
Yes. Well, what the process we go with is you send us your single line of the existing site, and we'll provide full technical proposal with a single line how this project would look like with repowering options. So that's kind of, we calculate all the string sizing, what you would need, and so forth. So yes, but we would need to have existing site single line, and then we go from there.
Great. Another question on that. Where would you suggest placing the new inverter?
That's a very good question. So with all those repowering projects, the uh, process typically would be if you don't want to run, because the DC runs are kind of long runs, there's a lot of strings at this point. Suggestion is to replace the existing combiner boxes with the inverters. So when you replace the existing combiner boxes, there is no penalty for the DC run. So the DC would come right into the inverter, and the only trenching or run will be is the AC run. In some cases, some of the DC runs from the combiner boxes could be utilized as an AC runs. In some cases, not. In some cases, you would need to have additional AC run. That's in most cases due to the multi-MPPT application and the way that lays itself out, the most common approach.
Great. And what about communications? What communication is supported on Solis inverters?
So Solis 1000-volt inverter supports RS-485 communication. The 1500 volts, which I showed, for example, the 255 and the 350 kilowatt inverters, they support RS-485 and PLC. So you could have either RS-485 or power line communication. In some projects, there are some legacy inverters that utilizes also power line communication. So those inverters could be direct replacement for those legacy inverters that are using power line communication.
Great. I think we have a couple of minutes left, so I have two more questions. Do you have, I know a lot of these old inverters were single MPPT and single input. Do you have single input on any of your inverters for combined strings?
Not currently. Not currently. We don't have all our inverters are multi-MPPT. There are some that are projected to be in the future with a single MPPT, but the challenge there will be low input voltage. So a lot of times the single MPPT inverters are a single stage inverter, meaning there is no boost stage in front of it, and it's just conversion from PV to inverter. And that usually would be ranging from anywhere 900 volt to 1500 volt range. So to repower sites that are 330 volt and so forth would require additional equipment, like some kind of boost conversion or some kind of PV DC to DC converter to be added for those single MPPT inverters. So those are kind of the other challenges with this.
Great. That makes a lot of sense. And the last question I have, I do see some questions still coming in the chat, so Zach's answering those. So please everyone keep sending those in. Last other question I have is, do you have a combiner box solution on the AC side to combine multiple new inverters?
Yes, we have a combiner box that is rated 800 volt, 1000 amps. It does use as a single protection or single fuse, where still, if you combine 6 or 8 inverters, it still would meet the requirement of short circuit current protection. And because the inverter is approved for protected device, it is UL protected device and current limited device, you could combine multiple inverters into one protection device and combine those inverters into that AC combiner. If there is during a fault or short circuit, the fuse would open, and it's a fast blow fuse, so it will open fairly quickly and will protect the inverter and the wiring.
Excellent. Thanks, Igor.
So thank you, everyone, for joining us today. This is our contact information, both for sales to get in touch with Ben and also our service and support. Please reach out. We'd love to hear from you and answer any other follow-up questions you had. And have a great day, and we'll see you on the next webinar. Thank you. Thanks, Igor.
Thank you, everyone. Thank you.
Everyone.
Thank you.